sort of like a forum session, to discuss with you some of the important parameters that you need to look out for in terms of ensuring the water purity. And also in choosing your water systems, what are some of the important parameters that you need to consider. So I'm glad that my service team will be actually supporting me for today's discussion with the customers. Also, when you look across the 38 participants, some of course is from our own company, but there are many participants from Singapore, Malaysia, Indonesia, as well as in Thailand. So the reason is that the Chemoscience group of companies is actually the exclusive distributor for ELGA laboratory water purification region, water system across the Southeast Asia region. So we are glad to have participants calling in, not just from Singapore. So if at any point in time you have any questions, you can either put it in the chat box, or we can discuss it along the way, raise your hand, or we can talk about it at the end of the session. Okay, so let me just go on to the slide now. Okay, so the good news is that for this session today, all right, we are not only going to talk about water, we are also going to have prizes for the customers. So before we go into the presentation format, we would like to get at least 2 customers to share their experience with us and their expectations of today's seminars. So so to get the ball rolling. So is there any customers who would like to voice out now what they expect to see in today's session? The first 2 customers who share their expectations will walk away with some special prizes from the company. Anyone? Any volunteers? No, they don't want prize.
No one volunteered for the prize.
Is there any customer who want to give it a try? No one. Or you prefer to type it in the chat box? Oh, Catherine. And also I believe Mr. Ho. Okay, so the importance of purified water in testing, and also to learn about water purification. Okay, so I will take note of your name, and thanks for sharing with us your expectation. Our sales rep will arrange for the special prizes to be sent to your laboratory. Thank you. We have more participants coming in now. Okay, so let's get on to the our session now. Okay, so I will leave you in the good hands of my service team. Fazli and Mr. Tan, over to you.
Okay, so probably we're going to cover a few topics, maybe about pH, conductivity versus resistivity, bacteria that you are having grow in the system. Then we talk about TOC, and the implication of the DNase RNase as the toxin free. So last but not least, choose the correct water grade. Okay, this one, in talking about purified water, okay, sometimes when this could be a little bit challenging, right, for every customer when they do this testing on pH. Okay, for in general, our system, right, it has to be neutral. So in your case, okay, on the right here, retrieve of the diagram. And there is a pH scale also. Okay, these 3 points.
Firstly, if the customer say they cannot hear you very well, can you repeat? You may need to remove your mask.
Oh, okay, sorry.
Okay. All right. So while Fazli is removing his mask, maybe I can cover him for this area. So I think that all of us know that a pure water needs to be neutral in pH because there should be no interferences, right? So sometimes when you actually draw the water from the water system and then measure with the benchtop pH meter, the result seems to be off. Either it's acidic or it's too basic. So in customers, it will trigger an alarm like, oh, is there something wrong with the water system? Or what's happening? So yes, anything that is not neutral for purified water is actually not ideal because it actually means that there is chemicals dissolved in the water and it will actually interfere with your results subsequently. So typically, engineers may be triggered to check on the customer system to make sure that the system is running well. But it doesn't mean that all the time, because of the measurement of your pH on the bench, it means that something is wrong with your system. Because it's really very difficult to measure the pH of purified water with a benchtop pH meter. So at this stage, I'll bring on Eng Xiang, who will share with you about the guideline by ISO 3696. Over to you, Mr.
Yeah, good morning, everyone. My name is Eng Xiang. I'm just a service engineer, so pardon me if I could not explain in details things that you want to know. Just excuse me. But as I have been working in chemoscience for so many years, I have few encounter with customer asking for pH. My pH is acidic. Why is it so? And they demanded us to come down to visit. And after doing a lot of testing on the system, we realized that there is actually nothing wrong with the system. That prompted me to really try to understand what does the pH actually measuring. So, sorry for my long-windedness, but pH actually measure hydrogen ions of the electrolytes of your solutions. So in water, as you know, purified water has very low conductance. Low conductance means there's almost no ion species in it. So therefore, it's actually not an electrolyte anymore, resulting in any interference such as your glassware, your CO2 in the air will actually dissolve it into the water, causing a rise in acidity. That's why you can see on the right the diagram, which I have taken some time ago, that the moment you dip your pH probes into the water, immediately it fall from 6.8 and you go down to 6, about 6, 6.8 to 6.5 almost instantaneously, and then you will start to drift further with time, and with further time you drift lower and lower. That took about 15 minutes, and the pH meter is still drifting. And mind you that this pH meter is not a portable type, but it was an expensive pH meters. So therefore, you can see the challenges of measuring pH. You can see the challenge of measuring pH, and is not really I would not say right or wrong, but it's not an appropriate way to determine your purity of your precious water. So in fact, look at the ISO. ISO has designated ISO 3696 as the international standard by using conductivity meter as a form of measuring inorganics by conductivity meter. If pH meter is the way to determine pure water, then all the water manufacturers would have incorporated this mechanism into the into the purifier, but that is not so. So probably you can still use a pH meter just as a very crude screening of your water, but most likely you will not get a neutral 7, but that because that is a theoretical numbers. Okay, so probably it's just my experience which I want to share with you. But if you want to go into details of how a pH meter works, you can actually check on the internet. There are a lot of tons of information over there, and it actually tells you why pH meter measuring pure water with pH is such a challenge. Okay, if you are still not sure of your water system performance, the best way to do, you can actually invest in a online resistivity meter, but that is going to cost you a bomb, because inline resistivity meter is in a price range of thousands of dollars, Sing dollars. So another probably a value added way is to engage a qualified service provider, whichever water system you purchase from, to provide a periodic maintenance and calibration service to ensure that whatever you see from the indicator of your purifier is true. Okay, I think I can pass it to my colleague on the next slides.
Can you all hear me better?
Yeah, Frosty, no problem.
Okay, all right. Okay, just pardon me just now for doing your first opening slide. Okay, now we move on to, thank you, Mr. Tan, for explaining on the pH.
No problem.
Okay, next we'll be moving on this conductivity and versus resistivity. Okay, as you know that some company, they prefer to use on those value, which is they prefer in microsiemens, okay, or maybe they prefer in mega ohms. All right, some water system, we can set this into these two values, okay, but in the end, what water purity that you are want, okay, what quality that you want it to be on display. So probably if you look on your right, okay, there is a conversion of these two value, which is mega ohms and microsiemens. Okay, if you see it works vice versa, okay, the highest in mega ohms will be 18.2. Okay, and the lowest conversion to conductivity will be in microsiemens, which is 0.055. So as you know, these two purity, right, for mega ohms, it will trigger to read the type 1 ultra pure, whereby the conductivity it will read on the type 3 water. So that's why you can see on this point, which is 1 US per cm is equal to 1 mega ohms. Correct. 1 mega ohms per cm or 0.055 per cm. So it's equal to 18.2, which is a mega ohms at 25 degree. So when you want to achieve this 25 degrees at highest purity, okay, in theoretical, okay, the highest will be 18.2. Okay, some user might say, or some other vendor also, you might have came across this water is even higher than this 18.2. So does it really matters? So actually, in fact, you need to have this compensated water, okay, which is to trigger at 25 degree. So when you see at this chart and also at this sample peak, right? So whenever this resistivity or conductivity, okay, it will also measure the temperature as well. So temperature is a crucial play part on this purity level.
Yeah, I think the message that we want to drive out to customer is that sometimes when from sales side we go out to talk to customers, some customer talk about what's the conductivity measurement on your system, and some customer will talk to us about what's the resistivity. So actually these two values are closely correlated. And as a general guideline, right, if you are talking about portable and type 3, we will recommend the usage of conductivity measurement. And then when we talk about type 1 and type 2, it's more on resistivity. I think it's more on the visual because of the converted values. Mr. Tan, anything else you want to add here so that, you know, we can keep this definition consistent throughout our discussion?
Yeah. Okay, actually, conductivity and resistivity are both like brother and sister. conductivity was used for measuring potable water or water from the reverse osmosis membrane is because there is still about 10% of ions inside. And these ions will have a very high conductivity. If you are going to use the mega ohms to represent it, it will be very difficult to understand how pure or how dirty the feed water is. Let me give you an example. Typically, a 10 microsiemens of RO water, which you can see on the right, the tab 3, if you go to read it in mega ohms, it will be 0.1 mega ohm. Which one would you like to read? A 10 microsiemens or a 0.1 mega? Personally, I would prefer 10 micro because no one would like to read a decimal point. Because 10 and 0.1, what you can see is 10, there is a two significant figure, whereas 0.1 is one significant figure. Let me give you another example. 2 microsiemens is equivalent to 0.5 mega ohm. So look at it, 2 microsiemens and 10 microsiemens. 2 microsiemens is of course a better purity of RO water than 0.1 mega ohm, but it's hard to visualize. So therefore, the industry has adopted using conductivity to measure the tap water or the tap 3 water. So in Singapore, water, typically our water range from 80 to about 260 microsiemens. For the new water that we have is even purer. It can go below 80 microsiemens. So therefore, to give you something outside of this slide, is that the new water that we have in Singapore is actually mixed with our reservoir water. So actually what we are drinking is not the new water because probably the new water is too pure and too pure for the piping. So new water is actually used in very dedicated industry such as semicon manufacturers. Okay, and I just want to add on a bit of the 15-25 degrees. There are some, probably including our salesman, will say that, oh, my system can provide 19 mega ohm, 20 mega ohm. You see, because resistivity is talking about how much of conductivity or how much of elasticity is able to pass through from point A, from point A to point B. So therefore, when you're talking about ions, ion is a function of temperature. A rise in temperature means that there is more mobility of the ions that is translated into lower resistance. Yeah. With a higher temperature, you will have a drop. You will have a drop in the resistivity reading. And when there is a drop, and if your water is not compensated to 25, you would think that your quality of water has dropped. But in fact, it's actually due to the relationship of the temperature.
Just kidding.
So likewise, if the temperature falls, you will have a rise of resistivity because the mobility of the ions reduced and the resistance increase.
4531.
So you have to know this relationship to understand why you need, when you're reading your water resistivity, you need to compensate it at 25 degrees. However, in some biological or pharmaceutical company, they will still want to read the water uncompensated, but they will do a calculation manually. That is part of their requirements, and our equipment does provide that options. Okay.
Yeah, so Mr. Tan, you're suggesting that, of course, it's a reminder to our salespeople as well as to customers that if anyone come in to tell you that we have a
This one is
water system that produce even more.
solvent,
Sorry, I think that we hear some background.
cell,
Maybe would you all like to mute your line?
tip and pin positioning.
I think Jaden, we can hear you. Can you mute your line, Jaden?
喂，等陣。
Yeah.
DO3 items only.
Jaden?
Say all 4 delivered. Never mind. I get the DO for this. I get the DO and see what.
Sorry, I will mute all of them.
The DO will say how many page on page, or just page 1 1.
Okay, so sorry. So, Mr. Tan, you are suggesting that if any of our salespeople or vendors actually claim that we have a water system that can produce more than 18.2 mega ohm, well, that's not really true, and it's probably because that would mean that they will have taken it at a temperature, the water temperature will be lower than 25. Am I right to say that?
Yes, you know, the system can report 19.2. Probably it is not compensated. That means it's not standardized at 25 degrees centigrade. So the question that the customer must ask is water compensated at 25 degrees? You need to be smart also lah.
Okay, so so the salespeople will have to be smarter. Okay, so anyway, I think it's good information for us, and also a gentle reminder to the customer. I think that the focal point should be at the 18.2 and not at whether it can produce 19 or 20. I think that's the message that we want to drive across.
To be exact, to be very exact, that's my weakness. It's actually 18.18.
Okay. All right. Okay, so watch out, participants, because later on there's 3 more prizes to be won. So we'll be asking questions about the presentation. So maybe the magic number of 18.19 will come out again. All right. Okay. All right. So let's go to the next slide. And Fasti, over to you.
Okay. All right. Okay. Now you move on to this view 3. Okay. About this bacteria. Okay. This is very sensitive, okay, for those labs. For example, those doing this bacteria culture, when they run this on this diagnostic lab, which is linked to analyzer. Okay, some they might thinking have this growth. Okay, when they do some collection, they do for sampling tests or micro tests. Okay, they found this bacterial growth or this. Okay, so there's a few factors that causing this. Okay, it could be from the filter block. Okay, it could be from the lab. Okay, they may have been arise so many factors into the system. So for us as engineer, right, normally we need to eliminate one by one. Okay, where is the collision point? How does this bacteria grow? Okay, but if you see that this UV lamp has been used for 2 ways. Okay, in water. Okay, which is to control the count. Okay, in main, it doesn't really kills the bacteria, but it tries to prevent this replicate growth in the system throughout this inline process. So ELGA also had adopted this flowing water, which is inline, which is Mr. Tan, which is already mentioned this water line, right, in the previous slide. So these offer much substance, okay, and effective of bacteria. Okay, so there's a few function that we can eliminate this when have this to kill the bacteria. So okay, Mr. Tan, do you want to elaborate more so that the customer can or this participant can have more understand on this?
Okay. As what my colleague Fasi has mentioned, filters does not really block or does not really kill. Kill is a very crude word. Actually, if you are a chemist, you know that the UV radiations will actually disrupt the replication of the genetic material of the bacteria. So, supposing you have a filter, but without a UV lamp, and if you're going to do a CFU test, you will see that the CFU will actually grow every week, because there is a point of time when the filter will be saturated with all the bacteria, all the fungi, all the viruses, to a point that it could no longer block anymore, and some of this bacteria will actually elute into the system. Therefore, you will see an exponential growth in your CFU plate count. Therefore, it's very important that your UV lamp do really works. And as my colleague has said, that adopting the inline UV lamp configuration is the best and most effective way of killing the bacteria. When I say kill here means it stop the bacteria from proliferating. That means growing exponentially. So therefore, another factor that determine your water from this bacterial attack is that the lamp radiation is proportional to the power, proportional to the intensity of the light. And the intensity of the light is also a function of the number of hours the lamp has been used. And the lamp usually will never fail. But and you will never know that when is the time to change the lamp. So therefore, it is really critical that you need to replace your lamp periodically, because it will never tell you that, oh, your lamp is dying, because unless there is a electrical failure, otherwise there is no error code other than a reminder that to tell you to change your lamp. If a lamp is not changed and the power from the radiation is not sufficient, it will not have the capacity to actually disrupt the DNA of the bacteria, and then will lead to uncontrollable growth of your bacteria. And when you collect the water and use it to do your experiment or any biochemical reaction, reaction will have a serious impact on your outcome of your experiments.
Okay. Besides UV lamp, I think that's quite common in system, and of course, we also mentioned that for ELGA we offer the inline UV, which is unique. I also recall that people talk about the importance of recirculation in water system. So maybe over to the engineer, how critical is this recirculation? Because I know that not all system comes with this recirculation. Some system will have disposable bags, to as their reservoirs, and then some vendors will not have recirculation, and then else on our system we boost recirculation. So what is your opinion on recirculation?
Okay, for this, having this regulation, right, mainly it's important to control the purity and also to control that there's no minimal growth system. But of course, I'm not saying that it's 0%, there is no growth. There is, okay, but having this circulation, right, we need this to prevent this minimal growth. That's why when the system having this supporting to those analyzer to your collection samples, right, so the system that recommend for those users, okay, we recommend to have this circulation function. Some customer, they just want to buy, for example, like standalone unit, okay, they just want a normal type water, okay, a normal grade, they don't require this ultra pure. Yes, we also do provide, but when come to service, okay, when during maintenance, okay, we have to perform all this disinfection. Okay, we need to so-called need to do some maintenance. We need to change all those filters for the vessel where the unit where the system fit to the reservoir. And as you know that when buying a single system benchtop, okay, the system is separated from the system. The tank is separated from the system. So we engineer also will perform a disinfectant to the tank. Okay, so we need to do a soaking, we need to do a flushing for fuel cycle.
So that means besides recirculation, periodic maintenance, whereby we do sanitization, is also important to help minimize bacterial growth, right?
Yes, correct.
Okay, all right. So good to hear that. Okay, so shall we push on? Let's continue. All right. So interesting subject, because when I promote my water system, sometimes customers say that they don't need to have the TOC monitor in the water system. So what they do is they collect the water, and then as a random test, they will test with their lab TOC monitor. So I want to hear from the engineer, because this happened to us in some of our discussion with customer. So maybe Mr. Tan, would you like to share with us how does this TOC, offline TOC work, and then is it really applicable, for to ensure the purity of the water?
Okay, thanks, Xiaohun. Okay, you may have asked me this question if you have listened carefully. Hey, resistivity, I thought you just told me that 18.2 megaohm is the indication of the purity of water. Yes, it is true, you are not wrong. But however, resistivity only measure the ionized salt, or which is your ions. That means your like ion activities. It does not measure your organic contaminants. Organic contaminants are those carbon-based solvents, anything that has that is carbon in nature. For example, if you go to add sugar to your pure water and you're going to measure it with a resistive meter, it will not change the resistivity at all because it's organic in nature and it does not contribute ions to the water. And to give you a little more information, that why you have resistivity in water is because electricity can pass through the water, not because of electrons, but because of the charged particles, which is the ions. They are both positive and negative. So therefore, in order to measure TOC, ELGA has adopted a proprietary technology where it can actually provide you with a real-time TOC. TOC is actually the total organic contaminants. It is indicate to you in real times, meaning that if there's any accidental contaminant that was introduced into the system, it will be indicated immediately. And when you have a total organic high TOC, you are suspecting of probably there is some high bacterial growth in your area, because when you have bacterial growth, you have decomposition in the bacteria that will lead to high carbon content in your water. So that again, that will have a very serious impact on your experiment, especially in cell culture, PCR, and even in liquid chromatography. So therefore, our system could provide TOC is one of the very important indicator of organic contaminants. And if you know in the market, one TOC instrumentation could cost you about 10 to 15,000. It's really very, very costly. And ELGA is able to provide you with this TOC real time. Is really a very cost-effective way for you to lower down your overhead in your lab operations. Probably I can just briefly go through the how it works. Actually, it makes use of two sensor, one before the UV and one after the UV. So what happened is that this UV is a special UV. It is a double wavelength. One wavelength is used to disrupt the DNA. The other UV lamp, the other wavelength is used to oxidize the carbon compound in the organic contaminants. And these two sensors works together and with the algorithm will actually calculate the total organic contaminants and report it out to the system. You can see on the image 001 TOC, and this is real time because the flow is continuously and recirculated back. If you can look at the diagram, a little bit small, but if you can look at the first sensor and the second sensor and the UV lamp. Okay, so therefore this UV lamp is critical and has to be regularly replaced so that the TOC reported is accurate and trustable. Yeah.
Thank you, Mr. Tan, for sharing. So I hope that clarifies on the importance of TOC, because actually it's a cost cutting if we remove the TOC from the water system. But I think that on our platforms we actually put in the TOC for, especially for the Type 1 system, as a mandate. Okay.
Sorry, Xiaohun. I
mm,
forgot to add one point. The unit of measurement for COCs is in ppb, part per billion.
mm. PPP, PPB.
PPB, yeah.
Okay, all right. Okay, so now endotoxin. I think that this is definitely of a great concern for customers who are in the biological arena, doing cell culture related work. So, Basti, you have a point of view filter with you, right? So can we have a
yes.
Cool.
okay.
Yeah.
Okay.
Okay,
So
if
we
you
cannot see. Can we see?
Can you see this? Okay, this is a biofilter. Okay, it also indicate the part number, all right, and then also there's expiry. Okay, normally it will depend on the usage. For example, for high usage, okay, you will recommend for 3 months. Then average usage for 6 months. Then the low usage will be 3 months. Also, it depends on those application process.
Okay.
So
I have a
better?
question, because I mean, it is definitely important, as most customers would use point of use filters as the like the final pardon me for my layman term, final cleaning to remove all the endotoxin. And some of the belief in the market, especially when they see the price of some of the filters, and then customers say, hey, why is it so expensive? I thought all kinds of filters can remove endotoxin. So, how would you share this piece of information with the customer, Mr. Tan?
Yeah, for me, all the filter look the same, all white, in a capsule form. Then why this one is $200, that one is $600? Then are you cheating me or not? So I mean, it's serious. I mean, nothing wrong with the customer. I would have asked the same question. So until I actually look at the details a little bit more, thanks to Xiaohun for asking me to release up. So what happened is that endotoxin, if you are a chemist, you know is actually a lipopolysaccharides. They are actually shed from the gram-negative bacteria when they die, and this thing when it will actually induce biological reactions. Supposing it's in our body, it will cause us to go into fever, because the cell in the macrophage cell will actually respond to it and cause us inflammations. So what happens is that our look at the graph on the right. There are two filters. One is a competitors. The red line is using ELGA filter. We actually what ELGA did was they concentrate the endotoxins. Sorry for my age, I can't see the number, but it's in terms of few 100,000 of EU per mil. E means endotoxin. E means endotoxin. So it's about few 100,000, and they challenge the water system, and they look at, and after that they do a testing, and they realize that even despite such a high loading of the endotoxins, it will still, after going through the filter, will still give you less than 0.00. It's almost not detectable. But look at another filter. It is, as the loading get higher and higher, it go higher and higher as well. So therefore, if I did not look at this chart, I would think that you are cheating me because the filter look the same. But once after I look at this chart, then I realize, hey, that is why you are paying an extra, because of the technology behind to actually remove the endotoxin, which, although I'm not a chemist or I'm not trained in this background, I know that if the endotoxin go into some of your chemical reaction or some biological chemical reaction, it will screw up your whole experiment. And I know that some of the reagents are very, very expensive. So probably you might want to consider to damage your experiment or to get a filter that really works.
So that means the
Okay.
recommendation to customer is that although it's just a filter, often very neglected, I would say that
Yes, yes.
customers pay a lot of attention, and even as sales ourselves, we promote a lot on the system, you know, how much water it can produce, how fast it can produce, and you know, type 1, type 2, type 3. We actually seldom talk to customer about the importance of point of use filter, honestly.
Yeah. So probably, of course, even without using the specialized filter, our water system could still remove endotoxin. However, we would like to would like to adopt a total approach. That means is a combination of UF plus this special filter to give you the the lowest level of endotoxin in contaminant in your water. So we are going in a total approach methods.
All right. Okay. So, so the next time maybe we should do blind tests with the filters. Okay. All right. So, yeah, I think that's yeah, that's myth number 5. Okay. So of course there are many myths out there, but I think we focus on the few key important myths. So I think that this will be the 5 typical you know, questions that we hear from the customers or we see from the market. That's why you know, we thought that with this short session, you know, we can clarify some of these misunderstanding in the market. So there's definitely more. Maybe the next time round when we have another second session, we can share with the customer in detail. So I think that with the important parameters covered, which we talk about pH, we talk about conductivity, resistivity, we talk about bacterial, we talk about TOC, and then now we talk about endotoxin. I think that, well, maybe it's timely that we share with customers some of the important points that they need to prioritize when they look out for a new water system, shall we?
Yeah, sure.
Okay. All right. So, Fazli, over to you.
Yeah, okay. We move on. All right. Okay. Sometimes when those sales they want to step in to learn to know more about what suits for them to use on their labs. Okay. Normally, ELGA has a few type of grade water. Okay, for type 3, type 2, type 2 plus, type 1, and type 1 plus. Okay, all these derive in a certain of purity level. Okay, it will also depend on what kind of application that you use. Okay, when we talk about like type 3, mainly for those like non-critical work, okay, which also include like, for example, glassware rinsing, water bath, those autoclave, and also it can disinfect feed is for this range of type 3 water. So, and then if you see for like conductivity, right, okay, it also show the range of 1 microsiemens to 50 microsiemens. And then as for type 2, okay, it comes with resistivity and also with conductivity, okay, because it produces an RO and also with PI. Okay, so normally it will like for general lab application, such as media preparation, pH solution, for and so on and so forth. Okay, for this type 2, and then it also have the range from 1 mega ohm to 10 mega ohms, and also in the system it also have this display of the microsiemens, which is reading the RO from the conductivity from raw water. Okay, which is from 1 to 0.1 microsiemens. And then as for type 2 plus, okay, mainly is more on the so-called a little bit higher specs, okay, for this spectrometry, those on this general chemistry, those microbiology analysis, okay, all this you can have this type of water. So if let's say you're talking about ultra pure, which is a type 1 and type 1 plus, okay, you're looking on the higher scales, which is more purity. That means you get more than 18. Like what Mr. Tan mentioned previously, so far he experienced the highest he can go at about maybe in decimal 18.18. See, so in general, normally the system will show on the highest purity at 18.2, which is on the type 1 plus. So this mainly is for the application like low level detection. like analytical instrument, critical R&D work. Okay, so if you are looking for these three types of application, which is because this type 1 water, you can have like analytical chemistry, life science, and also general science. So it depends how for the sales to explain what's actually equipment that and also what samples that you want in your process or experiment. So yeah, so these are the three types of water that you might also consider even based on your specification.
Yeah, so sometimes, I do hear this feedback from from our sales team, that when we ask customers about applications, customer may just say that, oh, it's lab use, lab use. I know everyone is very busy, so maybe sometimes customers may not have the time to discuss further with us, but it is actually very important for us to zoom into the specific particular applications. Because, for example, if you are only doing histology work, there may be no need for you to get a type 1 system. It's more costly, and it might be an overkill for you. So it is an appeal to our customers, as well as a reminder to our team that, always try to match back the applications to the type of water first, before we just offer a water system to the customer, or before customer just jump into, okay, I want XYZ model from this vendor. So I think the application to the type is more important than how the water system function itself. I think that's the prerequisite before we even talk about configuration. Okay? So, and other considerations to look out for, Mr. Tan, would you like to gently remind our customers, besides type 1, type 2, type 3 and applications, in the discussion with the vendors or in the discussion with their teammates, what are the things that they must consider before deciding on the system?
Yeah, okay, thank you. Can you go back to the previous slide? I want to add something. Probably you would see what's the difference between type 1 and type 1 plus. Actually, type 1 can also produce type 2. Actually, if you look at the indicator, it will also show 18.2. But what's the difference, if you ask? Okay, I give you an analogy. It's like going to Malaysia and going to Malaysia without buying an insurance. Going to Malaysia is actually very safe, but going to Malaysia with buying an insurance is even safer because you are insured. So type 1 is like going to Malaysia. Type 1 plus is like going to Malaysia with an insurance. What do I mean by that? When you buy a type 1 plus 18.2 in a water industry standard, is called a polisher. That means at any point of time, any minute, any hour, any day, any time, regardless, it will always give you 18.2. So there is always a capacity, there is always a redundant capacity that when the water fall below 18.2 is taken care by the first cartridges. That's why this is called a polisher. Whereas type 1 is not. Type 1 is not a polisher. If you are not careful and you are fallen out of your maintenance schedule, and the water may go below 18.1, very negligible, most likely will not see 18.0. Okay, so that is a difference between type 1 and type 2. And if you are in a water environmental lab detecting ultra trace matters in our water, then I probably would think that if I'm the lab manager, I will choose a type 1 plus, because I want to make sure I have an insurance that where any point of time I take my water is is 18.2 regardless. Okay, next slide please. So next slide. Yeah. Okay. Okay, what are the considerations to look out for? Probably you will ask how much water I'm going to use per day, and per day, per week, or per month. So this is important because that will determine whether we will recommend you the right capacity. Storage requirement also depends on whether you need to collect your water in batch mode or in ad hoc mode. If you're going to collect in batch mode, probably you may need a bigger carboy or a water tank. TOC monitoring is important when you do any biological or molecular things or PCR or microarray things. Then probably TOC is a very important contaminant that you have to look out for. UV lamp also works hand in hand with TOC. For general laboratory, you probably will need a simple UV lamp, but for TOC, you probably will require a wavelength that take care of TOC as well. I think recirculation function to me is really like a non-negotiable considerations because once you stop recirculation, you have bacterial growth. Whether your water is not sensitive to this bacteria, I think that recirculation is almost in all our water systems. Okay, so sanitization is to continue to make sure that our water systems meet the specification of our bacterial specification. Despite having a UV lamp to prevent microbial counts from increasing, we will still need to physically clean it with a sanitants. Just like our hands, even we have hand sanitizer, but after we reach home, we still have to wash it with soap to make sure everything is removed.
So firstly, on sanitization, is that something that we carry out in our maintenance schedule to the customers?
Yes, Yoon. This sanitization, or we call disinfection, right, we will perform during the maintenance. For example, it depends on how heavy their usage is, either quarterly, 6 months, or annually. It depends. Yep. And also, we also recommend, and during the health check and also PM, right, we also ensure that all these purity level is all within the specs, because when we perform all these health check, okay, all these checklists will be submitted as well together with the report. So anything abnormals arise during the maintenance side, we will also highlight this after the PM before we can hand over the system to the user.
Okay, and this is the part that I like, dispenser option. Sometimes I also don't understand or I get confused why so many dispenser option, right? So maybe can you share why is it important for customer to determine the correct dispensing options?
Okay, for this dispenser option, right, normally it comes in a lot of varieties. So normally what we listen to customer, yeah, I want a straightforward dispenser. Or we work multi-channel. So far, the unit is on the bench top, and then our office and our working area is quite a distance. So can we have a multiple? Yes, of course, we have an option. That's what you see in this tree picture, right? Okay, you can have a dispenser point from the system, and you can also add, okay, to have so-called multiple dispenser, which is we can extend to another few meters. Okay.
Okay. So that means it is good to discuss this also before a purchase, so that this is being installed and planned out. The piping is all done, correctly, right?
Yes.
Okay.
Can I add something? Yeah. Typically, a polisher tends to cost more than a single tier system. So therefore, another advantage of a dispenser is that it acts as a multiplier. So you can have a polisher, a type 1+ system, and then you want to multiply it. So you can actually add in a few more dispensers.
So the customer don't have to buy so many water systems.
Yes.
If their consumption is not so high for that particular grade water.
That is the point.
Okay.
worth considering lah.
Okay.
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 Yeah.
Yeah. So for our dear customer out there, if our sales team, need an hour to talk to you about the water system, please bear with them. I think they just want to get the configuration correct. Okay. Site check. I think that is something that, especially for chemo, we emphasize a lot on the site check. So what do we do during a site check, firstly?
Okay, when talking about this site check, normally we will do this so-called as a water analysis. Okay, normally, for example, after we confirm the orders, right? And then the first thing is to do a water analysis. That means all these site check required. So we will do some testing. We need to check like a pressure test, conductivity test, those like for example, when we're talking about analysis, right? So we need all these conductivity, chlorine, CO2 level, the water hardness, and also the pressure. So with all these, we have these specs. So from these specs, right, we can determine what system that we're going to offer to the customer. So basically, this is the standard requirement for site check when we perform this water analysis.
Okay, I think also another thing that we probably miss out here is pre-treatment. I think that this is also something often neglected, but I think we put a lot of emphasis and education to our existing customers. So to customers or potential customers out there, as well as colleagues, even for Singapore, we have a pretty good great water. We will still always recommend to have a pre-treatment before going into the water purifier, right, Mr. Tan? Can you can you share the importance? It's actually a very cheap filter, but often neglected.
Yeah, what Xiaowen say is actually really very cheap, but a pre-filter of 5 micron is important because most of the fouling things that can actually screw up the reverse osmosis membrane is the particles. Particles can come in 3 forms: colloidal, dispersion, and suspensions. All these can be taken care by the 5 micron filter to protect your expensive pre-treatment in your water system. So therefore, ensure that your water system is always properly pre-treated before this feed water is being feed into the water system. So for other sites where the conductivity is high, it is important to consider to use a bigger capacitor filtration housing. And
I got firstly to show us how does a pre-filter look like. I believe most customers will have seen it. Firstly, can you just show us?
Yeah, okay. Yeah, thank good. I'm so fast. I've just rushed back from site. Okay, if you so if you see this, okay,
cannot see.
Yeah.
You have to come closer.
Okay, can you see
Okay,
this?
so these are the pre-filters.
Yeah, this is the polemic filter, which is to prevent all those particle sands. Okay, you have a different size. This is 20-inch, right? 10-inch will be half of it. Okay, then this will be so-called. Normally, we will say this as a primary filter, okay, whereby the system will have this so-called is a carbon filter. So you can have you can have a 2-stage. Okay, so this is carbon filter.
Okay, so that's in the system.
This is external.
Okay, external. Okay,
Yeah,
so we can have 2-stage or we can have 1 stage also.
Yeah, normally for the system, it's really so-called the pre-treatment, right? It's already a carbon filter, which is this one. Yeah, so sometimes customer very kiasu. I want to install 2 filtration. That means they have total in 3 stages. Pre-carbon plus the inside system carbon filter also.
But there's also an advantage because the external is a very cheap filter. If we can remove most of the particles out there, right, actually the most expensive filters within the system could maybe be extended. The lifespans could be extended. Am I right to think in this way, Mr. Tan?
Yes. For that is quite true for particulates, but not true for organics.
Okay,
Yeah.
all right. So at least for the particle removal, it will help because sometimes customers' concern is that, how come we have rising costs of consumables? Why do we need to change so often? Actually, by putting in something really economical at the pre-treatment stage, it could actually be a lot of help for you as well. And it will discolor, right, when it actually get clogged?
Yes, correct. If you see from here, okay, I'm not self-color. If you see, okay, this is the white, okay, and this is white, and this is close to start to have light brown. Okay, these when we do the observation, right? Okay, when we do a replacement after 2 days, the color filter start to change already. That means the raw water from the industrial side or from the customer side is very, very poor.
Okay. Okay, sure. So there's a couple of customers who leave. I think that we should also check out time. I think it's about time for us to stop also. And you know, very much appreciated, you know, the service team as well as the Chemoscience group, you know, the regional team for joining the session, and also to our customers who call in. So don't go first because there's more prizes to be given away. And also just to remind everyone, Chemoscience and ELGA has been in partnership for more than 25 years, serving not only Singapore market, but Malaysia, Indonesia, Thailand, and Vietnam as well. So if you have any needs for water system or any questions, you know, or any concerns with your existing water system, not just on ELGA, feel free to contact us. All right. Okay, so now we are going to have a quiz. So it's about the speed of typing. So I have 3 questions here. So there's a Zoom chat box that everyone can utilize here. So the first 3 customers with the correct answer to 1, 2, and 3 will walk away with the last 3 prizes. So the first question is, you know, the recirculating function in a water system, what's the purpose? Is it to maintain the water temperature or to minimize bacterial growth? Quick, hurry. Second question, what is unique about ELGA's TOC monitoring function? It's not included in the system, so customer can buy, or it's real time? Oh, we see some answers coming in. So, okay, good. Wow.
So we need to divide the price, Yohun.
I see the graph. Chemoscience pilots are not eligible to participate. I'm sorry.
Yohun, is the price is this one free filter?
No, nobody want to participate.
Not the endotoxin filter.
Okay, so we have 3 complete answers already. I think the customers were paying attention to us, very appreciative. So we have, let me see, we have we have Chi Chi who has answered them correctly. Is B. We have Diane, we have Caleb as well. So the 3 of them will be notified, and then we will send the prizes over to you. And I mean, we're very thankful for all the customers who are sending in the answers. I hope you enjoy and find that this is a useful session. Our sales team will call you for feedback. So be it good or bad, give us your feedback, and we hope to see you soon. All right. Thanks a lot. Thank you very much. All right.
Bye-bye.
Bye-bye.